Good morning to all. In this lecture, we will going to see the next theorem, which is under SRSWR, derive an expression for sample size to estimate population proportion so as to meet the specified marginal error and confidence coefficient. Means here we want to find sample size small n. Here, when we want to estimate a population proportion, means when we want to estimate capital P. So, proof of this theorem. So, to find n such that probability of mod of small p minus capital P less than d is equal to 1 minus alpha. Capital P means your parameter and small p means your statistic. So this is your marginal error. Mod of statistic minus parameter. This is specified means this is less than d. And for specified confidence interval means probability of this less than d is equal to 1 minus alpha. We know under SRSWR sample proportion is an unbiased estimator of population proportion. And variance of sample proportion is capital P cube upon small n. This already we had seen in previous lectures. So if expected value of P is capital P and variance of P is this one, then P follows, small p follows, sample proportion follows asymptotically normal with mean capital P and variance capital PQ by small n. This is asymptotically. So, to convert this into standard normal, so here it will be small p minus its expectation or its mean is capital P and under root of its variance is capital PQ upon small n. This follows normal 0 1. So to solve this equation, we have to divide to convert this into standard normal or mod z. So we have to divide this by variance of p, root of variance of p. So rewrite by dividing the standard deviation of p on both sides of this mod of p minus p less than d, then we will get small p minus capital P upon root of PQ upon small n less than d upon root of PQ upon small n is equal to 1 minus alpha. This implies this is your z. So probability of mod z is less than d upon root of PQ upon small n is equal to 1 minus alpha. We know if z is your standard normal variable, then probability of mod z less than z alpha by 2 is equal to 1 minus alpha. Compare these two equations. Then we get d upon root of PQ upon small n is equal to z alpha by 2. And z alpha by 2 is obtained from table. So this implies we can write this as root of PQ upon small n. If I send in this side and this Z alpha by 2 in this side, so this becomes D upon Z alpha by 2. So I can write this as n upon PQ is equal to Z alpha by 2 by D. Take square on both sides. So after taking square on both sides, this will be n upon PQ and this will be Z alpha by 2 square upon D square. Send this PQ in this side, then we will get the formula for a sample size. So this will be n is equal to PQ into Z alpha by 2 by D square. So this is the formula for sample size. To determine a sample size, when you want to estimate a population proportion and for specified marginal error, and method is SRSWR. Usually this capital P is unknown. Q is actually 1 minus P. So usually this capital P is unknown. To estimate this capital P, we put its estimator, which is small p. So remark, and small p is obtained from sample. So we can put the estimators of this small p and q, and then we get the formula for sample size is usually p and q are unknown or not known. Then put its estimators small p and small q. Then n will be small p small q Z alpha by 2 by D square. Now consider the next theorem. Here method is without replacement. Under SRSWR, you want to find sample size, derive an expression for sample size. When to estimate a population proportion so as to meet the specified marginal error and confidence coefficient. So proof of this theorem. To find n such that probability of mod of small p minus capital P is less than D. This means specified marginal error, and for specified confidence coefficient. Under SRSWR, we know that expected value of small p is capital P. This means sample proportion is an unbiased estimator of population proportion, and variance of small p already we obtained, which is n minus n upon n minus 1 into pq upon n, capital PQ upon small n. So if expected value of p is this one and variance of p is this one, this means p follows asymptotically normal with mean capital P and variance n minus n upon n minus 1 pq upon small n. So this is asymptotically. Convert this into standard normal. How to convert this into standard normal? Take small p minus its expectation upon root of its variance. So this will be n minus n upon n minus 1 pq upon small n. This follows normal 0 1, and we denote standard normal variable by z. Now to convert this into standard normal, divide this by root of variance of p. So in this equation, therefore probability of mod of p minus capital P upon root of n minus n upon n minus 1 capital PQ upon n. Look at this equation. We divide this by root of variance of P less than d upon root of n minus n upon n minus 1 capital PQ upon small n, which is equal to 1 minus n. For a positive quantity, mod of that quantity is that quantity itself. So here we had written a mod and here we had not written a mod. So we can write mod also. So mod of this quantity is this quantity itself. Now when z is your standard normal variable, then probability of mod z less than z alpha by 2 is 1 minus alpha. Compare these two equations, then we get d upon root of n minus n upon n minus 1 capital PQ upon small n is equal to z alpha by 2. Now we have to solve this for small n because we want to find the sample size. This implies I can write this as d into root of n minus 1 upon small n upon root of capital N minus n into PQ is equal to z alpha by 2. Now after squaring on both sides, take d square, here it will be d square n minus 1 small n divided by n minus n PQ is equal to z alpha by 2 square. We have to solve this equation for small n. So I can write this as d square n minus 1 small n upon n PQ minus small n PQ is equal to z alpha by 2 square. So send this quantity in this side. So this will be d square n minus 1 small n, which is equal to n PQ z alpha by 2 square minus small n PQ z alpha by 2 square. So send this one in this side. So next step will be d square n minus 1 small n. So this becomes plus n PQ z alpha by 2 square is equal to capital N PQ z alpha by 2 square. Now from these two quantities, we can take small n common. So after taking small n common, in bracket there will be d square n minus 1 plus capital PQ z alpha by 2 square, which is equal to capital N PQ z alpha by 2 square. So send this one in this side. This will be n PQ z alpha by 2 square divided by d square n minus 1 plus PQ z alpha by 2 square. If we divide both sides by d square by n, then there will be npq z alpha by 2 square. Divide this side numerator by d square by n and denominator also by d square by n. D square n minus 1 plus pq z alpha by 2 square divided by d square by n. Now here this small n will get cancelled and n will be pq upon z alpha by 2 square z alpha by 2 square is a numerator, so this will be pq z alpha by 2 square upon d square whole divided by d square n minus 1. This is a d square n plus here it will be pq z alpha by 2 square d square n. This is equal to, I can write this as pq z alpha by 2 by d square whole divided by, here d square gets cancelled, I can write this as 1 minus 1 upon n plus I can take 1 upon n common from this one, so this will be 1 upon n into, in bracket it will be pq into z alpha by 2 by d square. So from these two quantities I can take 1 upon n common, so I can write this as pq z alpha by 2 by d square whole divided by 1 plus, take 1 upon n common, then in bracket it will be pq z alpha by 2 by d square minus 1. So this is the formula for small n. Sample size under SR is WOR. When we want to estimate a population proportion for a specified marginal error. Usually this P and Q are unknown, so we have to put their estimators. So remark number 1, usually P and Q are unknown. This is obtained from population. These are population parameters, so these are usually unknown. Then put its estimators. Small p and small q. So after putting their estimators, this formula will be small pq z alpha by 2 by d square divided by 1 plus 1 upon n small pq z alpha by 2 by d square minus 1. Second remark, if capital N is not given, if capital N is not given, we assume that capital N is very large than small n, then the approximate value of small n will be, if capital N is very large, means suppose it tends to infinity, then this quantity becomes 0 and small n will be now here. If this n tends to 0, then this quantity will become 0 and small n will be small pq into z alpha by 2 by d square. Thank you.